Okay, so we want to talk about reversing the multiplication with polynomials. And that's called factoring. So, for example, we want to factor x squared plus 13x plus 36. So we know this is the answer we get from the multiplication. And so we know that from the tiles or from the box, we know that we got 1x squared and we got 36 ones. Now, the 13x, that came from the combination of all the x's in these two boxes. So we know from building all the tiles that we did that we added the x's that were here in these two quadrants to come together and simplify to be that. So 13x is a combination here. Now, it's pretty clear that 1x times 1x gave us 1x squared here. But we now need to think about, and we have a little graphic organizer here if you would, we need to think about two things here that gave us 36 when we multiplied. So we're looking for two things that when we multiply give us 36, but when we add them give us 13x. So that when we do this, when we do these boxes, we get 13x. So thinking about factors of 36, and this is where we have to have good number sense, there's 6 and 6. Well, if I did 6x and 6x, that would be, if I think about 6x plus 6x, that would be 12x. That's close. That's not 13x. If I do 4 and 9, that would be 4. That would do it. And so thinking about this, this was 4x and 9x. Now, it doesn't matter which one's where. That's just the same as turning this, the whole square, you know, and we've talked about how it doesn't matter which factor you put where. So the 4x and the 9x can be flip-flopped, and that doesn't matter. It's just turning the rectangle. So this must have meant I had 4x's and 9x's. Well, 1x times 4 will give me 4x, and 1x times 9 will give me 9x, and 4 times 9 will give me 36. So my factors, or my factorization, is x plus 9 times x plus 4. That product equals the original problem, x squared plus 13x plus 36. Now, if I hadn't found the right combination, I just need to keep thinking about factors of 36. All right. Let's look at another one. So second example, what about x squared minus 21x plus 20? So again, thinking about my box, working backwards, I know that x squared came from here, 20 came from here. This had to be a 1x and a 1x to multiply to get together. Now I need to think about things that multiply together to give me 20. But the last one I didn't mention on purpose, because it's too much at once. On the last problem, it was all positive. So we were talking about two things that multiply to give me 36 and add together to give me the 13x, the positive 13x in the middle. Here, I need two things that multiply together to give me 20. Now, when I think about multiplying together to give me positive 20, that's a positive times a positive or a negative times a negative. But thinking about it, the middle term is a negative 21x. Well, if that's a negative, the only way I'm going to get these two things to add to be a negative in this situation right here is if I have two negatives. So I'm thinking about factors of 20, and they're going to have to be two negatives. Okay, so I already know these boxes are going to both be negatives. All right, so factors of 20. So 4 and 5, both of them being negative. Well, so that's adding them. That's not going to do it. That's negative 9, and I want negative 21x. That's not going to do it, so that's not right. So let's see, negative 2 and negative 10. Well, that's negative 12. That's not even anywhere close either. I mean, it's getting closer. I'm stuck. So another point, too, also to mention, a lot of people forget, is the negative 1 and the negative 20. A factor of everything is, don't forget the 1 and itself. Well, look at that. That combination will give me negative 21. So negative 1x and negative 20x must be the two things that I need. So again, it doesn't matter which one I put where. So when I do that, that must mean I put negative 20 here because that times that is negative 20. And here, 1x times negative 1 is negative 1x. And negative 20 times negative 1 is 20. So that all checks out in my boxes. So my factors are x minus 1 and x minus 20. If I had started with this problem and multiplied it, I would have gotten the x squared minus 21x plus 20 that I was originally given. Okay. So this structure over here can be helpful. As we get more difficult problems where the leading coefficient here in front is not a 1, this is going to be very important, and working with the box is going to be very important. So the more you force yourself to work with it now, the better. All right, the third example, x squared plus 3x minus 18. And I'm already noticing this one's negative, but this one's positive. So that's a little different than the last two problems. The last two problems, they were either both positive or both negative. X squared, negative 18, 1x and 1x gives me x squared. That checks out there. So I'm thinking about multiplying to be negative 18. Well, how do you multiply to get a negative number? I already know to multiply to get a negative number, the only way you can do that is a positive and a negative. So one of these is positive and one of these is negative. Then I need these two to, when they combine, to be 3x when we add them. Now I know I'm saying when you add them, because you add them. However, in your head, most of you think about, well, if they're opposite signs, you subtract the numbers and so forth and so on. So whatever you do in your head to make it work, that's fine. But that's important to think about. So now when we think about the combinations, we're thinking about negative 18, one positive, one negative. So let's see, I know that 2 and 9, one of these would have to be positive and one would have to be negative. So it doesn't, we can try it either way, but let's just say we do this. Well, that's going to make 7. And even if I turned it around, so even if I said, well, okay, make this positive 7 and make this negative 9, that's just going to make that negative 7. So that's not going to give us our 3 down here. Okay, well, I also know 18, don't forget your 18 and 1, and you could do positive and negative, but I think we just got further away from what we wanted, because those two together are negative 17. And if we changed it around, that would be positive 17, which is still not the 3 that we want. But if I do 6 and 3, and if I do negative, positive, that would be a negative 3 when I add them. So if I turn this around and I make that one the positive and that one the negative, that would give me my positive 3. So I want to make 6x here and negative 3x there. So it matters which one I make positive and which one I make negative. It doesn't matter which one I put in which box, but it matters which one I make positive and which one I make negative, because I got to get the right combination for the middle. So 6x, positive, negative 3x, negative. Okay? So 1x times 6 positive will give me the positive 6x. 1x times negative 3 will give me the negative 3x. And 6 times negative 3 is negative 18. So my factors are x minus 3 times x plus 6. And we could build this all with the tiles and try to figure out the tiles and the shape and then what works. It's the same idea. But most of us at this point have strong number sense enough to figure this out. At worst, if you get a number here that has a lot of factors, we might have to play with it a little bit more to get the factors, to get the right combo, to get the middle. But that's what it takes. Remember that your answer, this is what you're looking for. So this is what you should be writing down as your answer.